Hello and welcome back to everyone who's tuning in to this 2025 edition of the A4Q Testing Summit. I am very, very delighted and excited to welcome Julian Cambridge to join me. Hello, Julian.
Good afternoon, Debbie. How are you?
I'm very well, thank you. I hope the same for you. Julian, your first time with the A4Q Summit. You and I have known each other for a little while. I know that this is going to be an absolutely fantastic session. Julian, I'll give a tiny bit of background. You're a practicing tester and also an accredited ISTQB trainer. So I think you've got some credentials there. And I know a lot of useful information to share on sequential versus iterative testing. So I'm going to get off stage and leave it all to you in a moment. Just going to say quickly, if people do have questions, please pop it into the comments. And also at the end of the summit, we always have our best presentation, best speaker competition is the best word to describe it, I think. So please, everybody do go vote by going to the speakers page on the A4Q website, and you'll be able to say, yes, we loved Julian. So thank you very much. Julian, over to you.
Fantastic. Thank you, Debbie, and welcome to all of you. Now, my presentation today is revolved around two words there, sequential versus iterative. And I've titled this presentation, Testing Approaches Unveiled. Now, this is very much along the lines of the software development lifecycle model. Now, I'm sure there's many of you out there that know what the software development lifecycle model is. And for those that don't, I'll happily explain to you. Now, technology has very much taken over the world as we know it. Fast forward to present day in 2025, technology controls everything that we do. We check the trains, we use technology. We order food, we jump on our phones, and again, we use technology. We need to check our children's homework. Again, we're logging on an intranet page somewhere, and we are using technology to do so. But unfortunately, it wasn't always the case. When software got introduced, probably around sort of the 1960s, if you like, it was very much a new idea. It was very much a wow factor of we have got some element of technology and using it in a way that can change lives. Okay, and change lives it did. If you want to speak to someone across the seas, you jump on a WhatsApp video call or FaceTime call, and you're in the room with your relative or whoever it may be. Many organizations now have software as a service. They're replacing human beings with software that can do the jobs for you. Okay, so what a journey that we've been on. But it hasn't always been organized and structured. Some of you may say, well, it still isn't organized and structured. So if that's what you're thinking today, imagine how it was maybe 50, even 60 years ago, what technology was like then. Okay, we're talking about unplanned, a bit chaotic, not being managed, not knowing what's coming next. Okay, now we've got models in place where you've got the end user, the customer, the business that's asking for an element of software, and then a software development team happily coming along to build it. But what was it like before you had words such as sequential, before you had words such as iterative, which very much relate to a traditional way of working and an agile way of working? Two terms which we're going to go into far more detail at some point during this presentation there. But I'll just touch on how it all started and what was happening at the beginning. Very chaotic, not really knowing what stage of the process you're at. No model in place. And something had to change. Surely we could not go on like this. We're talking about missed deadlines, lack of structure, project failing. Okay, a lot of money invested and very, very little in return. But this was new. This was new to us. Who could blame us? Who could blame the world of technology? Not having a model to be able to judge where we are in the process. Not having something that we can track from beginning to end. So something had to change. We had to bring in a bit of order. We needed to bring in some consistency, some predictability. I'm conversing with end users, with customers, with other businesses. I need to be able to say, well, it will be done at such a point, and this is where we are now. I need to be able to track progress, perhaps a bit of quality control. But how do we do this? This is all just talking in the boardroom somewhere in the city of London or wherever it is in the world that you're logging in from. So what are we going to do about this? Well, this is where I've now got this topic in Testing Approaches Unveiled, which very much looks at the software testing side of things and exploring two different models that have very much addressed those issues. Okay. So with that model sort of non-existent, if you like, and very much just anything goes, we need to build this software, we need to release it, but there's no real order in how we do these things. Something had to change. And I'll tell you what did change. We introduced something like this. Now, this is what you call a sequential model. People may know it as waterfall. People may know it as a traditional approach. Gives a bit of structure, gives a bit of transparency, gives a bit of order. But what are these boxes all about? Well, you can see on the top left there, the first box is requirements. Well, this is what somebody wants. But why do I need to draw this? Isn't this the obvious? A business asking, well, this is exactly what I need to be able to have a development team build such software. But this just brings a bit of transparency. There's people that practice Kanban would say it visualizes the workflow. Well, I'm now going to visualize my requirements. And then once my requirements have come to a close, I'm going to pause. I'm going to stop and I'm going to say, have we done enough here? Are we on track? Shall we get feedback? Okay. So this model has come in to sort of clear up the issues around lack of order, lack of consistency, not being able to track progress, quality control missing, projects potentially failing, lack structure, missed deadlines. So a genius has come along somewhere and created this model, a sequential model. Perfect. This will solve all of our problems. So was said at the time. Well, it definitely helped. And it minimized the risk of further issues being created. So you've got requirements sort of on the top left there. This is what we need. This is what we need done. And then you've got sort of build, where you've got your developers coming in and saying, right, well, based on these requirements, we are going to build this. This is fantastic. All the requirements have been done. They've all been listed in some form of order or fashion. We just need to look at the requirements and build, and off we go. This is absolutely brilliant. Everyone's got their feet up, money well spent. And then we now go into the area which this summit is all about, testing, system test. The testers come along and say, does this work how it should do? Now, how was none of this done before? Well, perhaps this model did not exist, and that's why. So we've got testers that have come in to say, well, we've now done a bit of building, we've now done a bit of coding, development. Let's now test it to see if it works. And then you've then gone into acceptance testing, where the end user or the business comes in and says, we really like this. This is fantastic. We are going to sign it off. Or they might send it back, give you a bit of feedback and say, oh, well, we're not really too sure. And then we then go into the last word of deploy, where we hand it over to the customer. We hand it over to the business and say, we are done. Isn't this brilliant? So let's do a bit of a recap on this model here. The business say, this is what we want, and we've got requirements. And then we've got build, the developer acts on those requirements and gets going. And then you've got test, where, you know, people that are watching this summit will very much be like, well, that's us. He's talking about you and I. Testing. Acceptance testing then comes along, and deploy. Again, it's all come in to fix chaos, missed deadlines, lack of structure, project failures. Just drawing it out and having it visualized solved so many problems. And then testing came in and said, well, we can test as early as possible. We don't need to wait until it comes into system test. We can get in early. We can start testing as early as possible. If we find all the issues and requirements, by the time it comes to system test and acceptance testing, it's all smooth sailing from there. So let's be quite annoying. Let's get in early into these requirements and start testing from there. Absolutely brilliant. Sounds fantastic. Nothing can go wrong. This is it. Life-changing. Let's get Microsoft Office, Windows 95, all these great softwares that have come about using this sequential, waterfall, traditional approach type model. Isn't this fantastic? Nothing can go wrong. So they say, And then someone somewhere gave some requirements, developers built, testers tested, and then got to acceptance testing and said, oh, sort of changed my mind now. I've changed my mind. Those requirements that I gave you were that was last year's wish list. Today, I want something else. Have you not seen what the competitor across the road is doing? We need something else. We need to compete with the market. So I need my requirements to change. Testers chucked everything in the air. Developers chucked the code in the air. We need to go back and do it all again, they said. But this doesn't sound like it solved any issues. We're now back to chaotic. We're now back to missed deadlines. We're now back to lack of structure. We're now back to project failures. Well, I thought this was the model that came to save our lives, if you like. Well, it's a fantastic model. Look at it. From requirements down to deploy, it is absolutely brilliant. Until a change is needed or mass change is needed. How do you then go back? All the arrows are going forward. How do you then go back a step? How do you go back to requirements and say, right, we need to add 10 more, or we need to scrap some requirements, take some out, and then bring some in? How do we do all of this? And this is where there was a bit of an issue. It's a bit of a problem. As great as this model is, what do we then do? Well, that was the word sequential. The word iterative then came around. What is iterative? Well, someone said that iterative is where you can change your mind. What do you mean iterative is where you can change your mind? Give me a bit more than that. Well, iterative is exactly that. You can change your mind. Okay, perfect. Well, he said iterative approach. We're all changing our mind. Problem sorted. So now what do we do? Sort of still in the same place, but it sounded good for all of 10 seconds when you said it. And then someone said, well, if you're going to change your mind and you're going to change the model from sequential to iterative, you probably need to draw it again. Well, what do you mean draw it again? This drawing is perfect. This is brilliant. We've got requirements all the way down to deploy. How are we going to draw this model again to talk about this iterative approach of changing your mind and adding new requirements and all the other stuff you were going on about? No one understands what you're talking about. You can't change your mind. Surely this is the sequential model. You do not change your mind. Requirements are the requirements. So again, someone said, well, redraw the model. Well, what does that look like? Oh, well, this is how we redraw the model. Just a cycle going round and round and round. It's just quite repetitive. It's like a cycle. And you've got someone in the middle looking like they're running at full speed. Is that a sprint? Are they sprinting away into the distance there? So what does this look like then? How do we just do the project over and over and over again? Are we just going round and round? Someone said, no, actually, I've got a better idea. So I said, what's your better idea? Well, my better idea is you just taking a few requirements at a time. Okay, now you're going to need to explain this because I'm absolutely lost. 1 minute is changing your mind. Now it's taking a few things at a time. Tell me exactly what it is. Well, what we're going to do, we've got a list of 100 requirements. Let's say you've got a list of 100 requirements. Sounds about right. We're going to take 10. What do you mean we'll take 10? What happens to the other 90? Well, that's the changing your mind area. Stay with me. I think we're going somewhere with this. We'll take 10 requirements, put them into the cycle, do a bit of building, do a bit of system testing, a bit of acceptance testing, and then deploy, and then bring in the other 10. I think everyone's listening now. And then we've got the customer or the end business user or whoever they may be in the room saying, I like those 10 requirements, bring in the next 10. And we'll keep doing this and we'll call it iterative approach. We'll call it a cycle. We'll call it agile. We'll call it being able to change your mind. So the requirements that we haven't worked on yet, well, we can do what we want with those. We don't even need to bring those in. There could be duplicates. We may need to take one away. So this is the iterative approach. So now we've had two solutions to solve problems. What were those problems? Software development starting all the way back in the 1960s, chaotic, not a model in place, missed deadlines, no structure available, projects failing, no order, no consistency, predictability all over the place, unable to track progress, no quality control. Let's bring in a model. There you go. Diagram solves all your problems. And it did. It largely did. It largely did solve all the problems. You've then got stages which break down the software development lifecycle in your requirements, your build, system test, and so forth. And that gave order, that gave structure, that gave visibility and transparency. Then somebody wanted to change their mind, came and ruined it for everyone. Well, here we are, an iterative approach where we're bringing in 10 requirements every time. So what does that mean for you and I as testers? Well, we've sort of broken it down. When you've got the requirements area, you've got a bit of static testing where it's very much reviewing, if you like. You're reviewing the requirements. Nothing's been built yet. Okay, and you're giving your feedback, hoping to find as many issues in this area as possible, because this is where it's most cheaper. If I can get into your requirements and say, well, actually, I'm not sure about this, you may need to have a look, a bit of a closer look here, as opposed to finding that same issue in system test or acceptance testing, I could be saving a lot of money here, saving you a lot of money. And then you've got build, and then you've got developers that do a bit of testing there. So in every stage, we can account for the testing that we're doing. You can see it there on the screen. In build, you can do a bit of unit testing, a bit of component testing. And then in system test, you then sort of moved away from static, and here you are with dynamic testing, bit of functional testing, a bit of defect retesting, okay? You raised a defect, they've fixed it, it's come back, doing a bit of confirmation defect retesting. And then you've got acceptance testing. The end user comes in and says, right, let's have a look at this. But acceptance testing has been happening all throughout. If you've got an iterative approach, if you've got a sequential approach, they come in at the end, or very much so, and give their feedback and opinion there. Nothing wrong with that if nobody changes their mind. And then we come back to that phrase again. And with acceptance testing, you've got beta testing, prototype. Have a play around with this. Tell me how it makes you feel there. Okay. I remember beta testing when computer games used to come out in the 90s, and it would give you the first 2 levels to play as opposed to playing the whole game. And then you can give feedback. Performance testing, is this fit for purpose? Can we have X amount of users on this all at the same time without the speed of the functionality lagging? Acceptance testing. And then once we give it over to the user, deploy, what happens when it then goes into the public domain? Do we then need to maintain it? About maintenance, regression, very much if there's a change, does everything else still work? If you've got a change to the software, has it broken anything else? And this is where we are. And if you look at where we started from way back in the 60s or whenever it may have been, and you look at where we are now, we still have problems today. It's still not perfect. But we've brought in models, one being iterative, one being sequential, different approaches, different mindsets, and we've illustrated a model out. And you've seen those on the 2 previous slides. One was very much like a staircase, one box after the other. And then one was very much like a circle where it's just going round and round, very much a sprint, a cycle, an iteration. And we believe we've made mass progress in the area of software development. We believe we've made mass progress in the area of software testing within software development. And you can see it on the screen there, looking at those 5 different stages. Now, these are the 5 different stages that are in this presentation. You've got models in every other organization and every other culture of software development that may alter the words a little. You might have requirements and then the design might be in there, as opposed to going straight to build. You might have design that sits in between the 2. Okay. But either or, you've got a direction of travel. And our direction of travel is start with requirements and then end at deploy, with all these other stages in between. And when you get to the end of every stage, you've got a bit of a quality gate. Are we sure? Are we happy with this? We can communicate this out to stakeholders, communicate this out to interested parties, and we can minimize project failure. We apply structure. We meet those deadlines. Or if not, we communicate those. We make it less chaotic. We can track progress. We've got some good quality control. Ultimately, it's consistent. Everybody knows what they are doing and how. And that's where we look at testing approaches unveiled with sequential versus iterative. I'll go ahead and take a few questions, but thank you for listening to the last few slides.
Thank you ever so much, Julian. Lots of good information there. I know we've got some questions, so I'm going to ask the people backstage who can pop them onto the screen for us. What are the cost implications on testing moving from a sequential way of working to an iterative way?
Very interesting question, because a sequential way of working is very much, it's been ingrained in people. It's your way of used to working. And then all of a sudden now it's, well, let's change from sequential and let's go over to iterative. So you can only imagine there'll be upfront costs, stuff like training, new tools that you may need to use, the cost of frequent communication, more meetings, more collaboration. These are the sort of the upfront costs that we're looking at when we're looking at sequential and iterative. But then again, on the flip side, you may look at the long-term savings as well, because you're getting constant feedback. You're not delivering a whole backlog and then having to then say, well, it's now a waste of time and the customer doesn't want it. We're delivering in sort of digestible chunks and iterations, if you like. But then again, you've got sort of ongoing maintenance as well, because this is a cycle. We're constantly sort of deploying, if you saw the word that was used in the development model that I used there. We're constantly releasing or presenting to the customer. So I would say there's quite an upfront cost in terms of change, but in terms of return on investment long-term, customer gets what they want, and there's no better cost than that.
Thank you, Julian. See if we've got some more questions. With the constant welcome of new requirements, I like that phrase, is there a fear of change fatigue when testing and iterations?
There can be change fatigue. If every time you get through a cycle, it's change, you'd be a bit fed up, surely. You have no direction of travel. It's not sustainable to constantly be changing. But then when you've got good communication, good planning, good collaboration in place, it very much minimizes that. And if there is constant change and it's creating change fatigue, then your way of working is failing. The communication is failing. Things aren't transparent enough up front. The direction of travel, the goal of what the business or the customer is trying to achieve isn't clear. So yes, there can be change fatigue, but if there's change fatigue, it's revealing a whole host of other issues that you and your team might have, which probably need to have further attention to them.
We could have a whole conversation about that one, Julian, I'm sure. And I think we've got time for one last question. If a tester in either approach raises minimal defects, are they adding value? Is it just as valuable to find no defects as it is to find defects?
Very, very, very good question. The word quality comes to mind. This is what testers are all about. A tester's job description is not necessarily, are you finding defects? A tester's job description is very much, are you ensuring quality? And what does quality look like? Giving confidence, building confidence in the product, and being able to hand over to that product to say, we are very confident that this is a product that will work for you and minimize the risk of any issues. But we've all been testers, or a lot of us on this conference are testers. And perhaps when you're working through that week and you haven't raised a defect, it's very much, oh, have I done my job? Or if I've raised too many defects, on the other hand, do you feel like you're doing a great job? But it's not just about the defects. It's very much more the overall quality, the user experience. Will this user enjoy using such an application? So I would say they're adding value regardless, because it's quality control. Okay, you're adding value to say, we have checked this. These are the scenarios that we've checked them against. These are the test cases that we've executed. And these are the results that have come back. Whether it's minimal defects or a ton of defects, we are ensuring quality either way.
That's wonderful. A wonderful way to end the session, Julian. Thank you very, very much indeed. Just a reminder to people, please go to Julian's profile on the A4Q Summit Testing Summit website if you would like to vote for his presentation. Julian, thanks. That was smashing. Thank you ever so much.
You're very welcome, Debbie. Thank you.
That's great. And everyone stay tuned for the next session. Cheerio. Bye-bye.